These are the workhorses of gold labeling. They're catalytic reactions that deposit silver or gold selectively onto gold nanoparticles. You can use them to enlarge even small gold nanoparticles like our 1.4 nanometer Nanogold up to 30 to 100 nanometers in diameter, or even larger. This makes Nanogold visible, or more clearly visible, by electron microscopy. You can visualize Nanogold staining on blots or gels by light microscopy, or for optical detection or reading. And this makes a super sensitive detection method for blots and gels. Silver enhancement is the deposition of silver onto gold nanoparticles. It happens when you expose gold nanoparticles to a mixture of silver 1 ions and a reducing agent. Without the gold nanoparticles, this reaction has a long induction period, so essentially nothing happens for about half an hour or so. But in the presence of gold nanoparticles, it's catalyzed, proceeds immediately, and silver starts depositing onto the surface of the gold. A short period of enhancement to enlarge the gold nanoparticles up to maybe 5 or 10 nanometers is a very useful visualization method for electron microscopy. And here's an example of this. This is our Nanogold FAB prime, goat anti-rabbit conjugate, used to label the potassium channel of the Kv2.1 subunit in rat brain, localizing it exactly to the cytoplasmic side of the cell membrane and the stacks of the Golgi. If you take the reaction a little bit further and grow the particles larger, it becomes a great visualization method for light microscopy. And here's an example of this. On the left is the visualization of microtubules by Nanogold with silver enhancement, and on the right the visualization of microtubules by colloidal gold labeling. As you can see, they're much more clearly defined with Nanogold plus silver enhancement. If you take the reaction further still, it becomes a super-sensitive visualization method for blotting. And here we see a comparison between silver-enhanced Nanogold, which is the blot on the left, and a 15 nanometer colloidal gold on the right. Both are being used to detect an IgG target, which has been spotted in serial dilutions onto the membrane. And as you can see from the keys underneath each blot, the last visible spot on the Nanogold blot contains just 0.1 picograms of the target IgG. The last visible spot on the colloidal gold blot contains 1 nanogram of target IgG. So Nanogold, even though it's a smaller gold nanoparticle, when it's used with silver enhancement, is about 10,000 times more sensitive than colloidal gold. So that's silver enhancement. Grow nanoparticles up from 1.4 nanometers to as large as 30 to 100 nanometers or larger. Great for electron microscopy, light microscopy, and blotting. Silver enhancers from nanoprobes are available in 2 flavors. HQ silver, which is optimized for electron microscopy. It has low ionic strength and near neutral pH for a good ultrastructural preservation. Has 3 components and contains a protective colloid that ensures uniform enhancement and consistent spherical particle morphology. And this is very similar to homemade enhancers such as the Dansha formulation. And our other flavor is Li silver, or light insensitive silver, which is a multi-purpose silver enhancer which contains other additives that control the reaction rate. Has a greater ionic strength, similar to many other commercial formulations of silver enhancers, and is just 2 components. Silver enhancement with Nanogold can be used for double labeling, where the silver enhanced Nanogold provides a punctate labeling of specific, unique targets, while a second visualization method, in this case enzymatic staining with diaminobenzidine, creates a diffuse aerial staining for labeling a second target. You can also use silver enhancement with Nanogold for double labeling. You can use differential silver enhancement, in which you label a first target with Nanogold, then silver enhance, then label a second target with a second Nanogold probe, and silver enhance again to create 2 populations of non-overlapping sizes, where the first target, where the Nanogold has been silver enhanced twice, is labeled with much larger nanoparticles than the second one, which has only been silver enhanced once. Another approach to double labeling is to use silver-enhanced nanogold to label one target and a larger or smaller colloidal gold particle to label a second target. And here's an example of this with silver-enhanced nanogold. In this case, the smaller of the particles labeling a membrane-associated target and a 30 nanometer colloidal gold probe labeling a second target. However, silver is not perfect. It does have a few disadvantages for some applications. It has a lower atomic number than gold, so contrast is less, and sometimes larger particles are needed for visualization. Silver is also precipitated by some anions, such as halides, and this can lead to background, particularly in physiological buffers and physiological systems. Silver can be etched by osmium tetroxide, especially in combination with uranyl acetate. And the three-component viscous formulation of HQ silver can make it a little difficult to work with. And the protective colloid can also be degraded by repeated freeze-thaw cycles. And in some cases, endogenous redox catalysts can produce background with silver enhancement. In this case, there is an alternative, gold enhancement. Gold enhancement is very similar to silver enhancement, except that the metal that's deposited is gold, not silver. Gold enhancement provides a low background, it's not etched by osmium, it's less pH dependent than silver, and it can be used in physiological buffers because gold is not precipitated by halides or many other common anions. The gold enhancement reagents are stable, non-viscous, and easy to mix and use. Here's an example of gold enhancement for electron microscopy, and just a brief period of gold enhancement gives 5 or 10 nanometer gold nanoparticles which have a high contrast and are very clearly visible. For example, in this immunolabeling of a Golgi matrix protein, GM130, using nanogold ferroprime with gold enhanced EM formulation. Uniform enlarged particles with very high contrast. Here's another example, scanning electron microscopy. Now, gold enhancement is uniquely valuable for scanning electron microscopy because gold provides a much stronger backscattered signal than silver. So you can visualize gold labeling with high sensitivity by backscatter detection against a background of the underlying structure with secondary electron imaging. So in this case, the backscatter signal has been colored in gold to show the gold labeling. And this is a 45S rDNA in the nucleolus organizing region of a plant chromosome, and showing the gold localized to a constriction in the plant chromosome. Taking gold enhancement further provides a very sensitive detection method for light microscopy, and again for blots and gels. And this is GoldiBlot, which is our product for Western blot detection. GoldiBlot is a system for detecting his-tagged proteins on Western blots, and it consists of our nickel NTA nanogold, which binds strongly and selectively to his-tagged proteins, developed with Gold Enhance. And here's an example of the visualization of his-tagged proteins on a Western blot. In summary, you use gold enhancement when you have a risk of etching of silver from osmium tetroxide, where gold is stable. It often has lower background than silver, gives a much better backscatter signal than silver for SEM, compatible with physiological buffers like halides. It's less pH sensitive than silver. The components have a low viscosity, so they're easy to mix and use accurately. And also compatible with a wide variety of substrates, even including cells cultured on metal substrates. For more information, please contact us. You can email us at nano.sales@nanoprobes.com. Technical support is available at tech@nanoprobes.com. And for more information, call us at 631-205-9490, or better still, go to our website at nanoprobes.com. And our website's the best source of information for all of our products and their applications. Thank you very much for your attention. We hope you've enjoyed this presentation, and good luck with all of your labeling experiments.